Hi everyone, welcome back to my channel. We have discussed about a method you can apply to determine the number of factors to be retained in EFA in the last video. In this video, we are going to continue with how to decide the rotation method used in EFA and how to interpret the tables or outputs of different rotation methods. Based on the article by Brown published in 2009, he had compiled the definitions of rotations from past literatures. For example, McDonald defined rotation as performing arithmetic to obtain a new set of factor loadings from a given set. In simple, rotation is conducted in order for us to obtain a simpler structure of loadings that allow us to interpret the factors. There are two main categories of rotation, orthogonal and oblique rotation. In SPSS, 5 types of rotation are provided. For orthogonal, you can opt for Varimax, Quatermax, and Equimax, whereas for oblique rotation, there are 2 options, which are direct oblique and Promax. How are we going to choose among the rotation methods? We have to return to our assumption towards the constructs included in the study. If you are assuming there is no correlation between the factors or construct, then orthogonal rotation can be used in your analysis. However, in social sciences, we generally expected some extent of correlation between the factors since behavior is a complex product from many factors. Therefore, oblique rotation can be applied when you are assuming there is correlation among the variables. Now, let's work on our example and see how the procedures work. Similar to the procedures we had learned in the last few videos, first we go to Analyze, Dimension Reduction, and select Factor. Select all the items and put it into the Variables column. For descriptives, we can retain the selection we have ticked in the previous analysis. Then we go to Extraction. For this analysis, we will use PAF. Remember that we have made the decision of retaining 4 factors to be extracted based on a series of analyses such as Kaiser criteria and script plot. So we type in 4 in a given column and select Continue. The next step, we will select Rotation. Choose the rotation method based on your assumption among the variables. If you expected there are no correlation among the factors, then you can go for orthogonal rotation. Among orthogonal rotation options provided in SPSS, Varimax is the most used method. But if you think there are some extent of correlation existed among the factors, then you can try oblique rotation. Thompson had recommended the use of Promax rotation as the more desirable oblique rotation option. However, if you are not sure about the correlation among the latent variables, you are advised to use oblique rotation too, as if there are no correlation existed among the variables, the output of the oblique rotation will be similar to that resulted from the orthogonal rotation. The last step to consider before running the analysis is to determine the coefficient display format. Let's go to Option and tick Suppress Small Coefficient. You can set the values to be suppressed at 0.3 or 0.4 by using relevant literatures to support your choice. In this demonstration, I will use 0.3 as the cutoff point. Then hit the OK button and go to Output Viewer. At this point, we will focus on 3 tables, which are factor matrix, pattern matrix, and structure matrix. If you are using orthogonal rotation, for example Varimax rotation, you will see only 2 tables, which are factor matrix and rotated factor matrix. So for orthogonal rotation, we will report and interpret the result from rotated factor matrix only, while we need to report 2 outputs for oblique rotation. The pattern matrix, which is used to examine the factor loading, and structure matrix that reports on the correlations between the items and the latent variables. The factor matrix represents the unrotated factor loadings, generally is not of our interest to be interpreted. We'll examine the pattern matrix for item loadings. We will exclude the items with loading less than 0.3, which we have suppressed in the analysis. Second, identify the cross-loading items, which are the items loaded on two or more factors. Past literatures advise that cross-loading items with a coefficient more than 0.32 on two factors should be deleted. These items show cross-loading issue, so we are planned to delete the item in our later analysis. Then we will look at the number of items within each construct. Hare suggested that each latent construct should contain at least 3 items to be better explained. And if you are going to continue your analysis with confirmatory factor analysis CFA, it is advisable to have at least 3 items, or else you will be facing identification issue when conducting CFA analysis. Now let's look at the structure matrix. By examining the structure matrix, we can conclude that the items in the first dimensions have correlations with factor 2, and the items from factor 2 also have some extent of correlation with latent construct 1. Some of the items even show correlations with more than 2 dimensions. You can see this example here, attitude 3, which shows that these items have correlation with the first dimension, second dimension, also with fourth dimension. The last part of this video is to report your findings by describing the factors and its components. So what we are going to include in your analysis are the number of items, the cutoff point to include an item. Some chooses 0.3 or 0.4. Last but not least, report the items removed from the instrument and state the reason of deletion, such as low factor loading or cross-loading on 2 or more factors. That's all for today's video. Hope you enjoyed the tutorial and the information from this session could be useful for your research. Thank you and see you soon.